Good morning, ma'am. This is Sadia Anju from the Department of Computer Science and Engineering from Section E, first BTech, second semester. So my topic for the second assignment is capacitor filter and no analysis. Let's move to my topic, capacitor filters. We will study their fundamentals and applications. In further slides, capacitor filters are essential electronic components. They are used for signal conditioning in circuits. They are critical in power supplies and signal processing. Capacitors find use across electronics, telecommunications, and automotive industries. So generally, capacitors are that stores the energy. So here are the capacitor filters. They're used across electronics, telecommunications, automotive industries also. They are generally used for signal conditioning in the circuits. These capacitor filters are used in circuits mainly. They are critical in power supplies and signal processing. They are very useful in the power supplies and signal processing. Okay. So we will study about these essential electronic components called capacitor filters, more details in further details like exploring types of capacitor filters, low pass filters, high pass filters, band pass filters. So these are the types of capacitor filters. So these three types of filters we have under these essential electronic components that are used in circuits called capacitor filters. So low pass filters, first of all, these low pass filters allow low frequency signals to pass, block high frequency signals effectively. We have learned in the back slide that these essential electronic components are essential for allowing signals in the circuits. So these type of low pass filters, they pass and they allow low frequency signals in circuits rather than high frequency. Instead of allowing low frequency signals, they also block high frequency signals effectively. So next, high pass filters permit high frequency signals, block low frequency signals from passing through. So as opposite to the low pass filters, these high pass filters, they permit very high frequency signals in the circuits compared to low pass filters. And generally, as low pass filters blocks the high frequency signals to pass through the capacitor filters effectively, these high pass filters also block low frequency signals from passing through the circuit effectively. And the third type is band pass filters. These band pass filters allow signals within a specific range, block frequencies outside this range. So from this we understood that these band pass filters have specific range, some points of ranges in which only these allow the signals to pass through in the whole circuit. So out of these ranges, they block the frequencies, whatever they may be. Thus, so these are the conditional band pass, conditional capacitor filters, as they allow the signals, frequency signals in the circuits in a specific range only and block the frequencies outside this range. So we have explored the all three types of capacitor filters like low pass filters, high pass filters, and band pass filters. Low pass filters allow low frequency signals to pass through in the circuit. High pass filters permit very high range of frequency signals to pass through in the circuits. And as we learnt about band pass filters, they are conditional and they have some specific range, and only in that range they allow the frequency signals to pass through in the circuits. Okay, let's move to the other slides. In this slide, we learn about basic principle of capacitor filter operations. Means we will learn on which principles, on which topics this capacitor filter works and what are the principle behind the operation of these capacitor filters. Okay, so firstly frequency dependent impedance, block DC, pass AC, and noise reduction. Noise reduction reduces noise. So first of all, frequency dependent impedance. Impedance varies with frequency. Means here the frequency depends on impedance. So as the impedance varies, frequency also varies. Or if frequency increases, impedance increases. If frequency decreases, impedance also decreases. Means here the impedance is dependent on the frequency. As the frequency increases, this impedance also increases. If the frequency decreases, then also this impedance decreases. Next, block DC, pass AC. Blocks direct current, passes alternating current. Here, the another principle is it blocks the direct current to allow the passing or transformation or movement of alternating current. In order to pass the alternating current, it blocks the direct current. And noise reduction, it reduces noise and some small sounds, etc. So these are the three basic principles of capacitor filters, or the basic principles behind the operation or working behind capacitor filters, that are frequency dependent impedance, block DC, pass AC, noise reduction. Let's move key performance parameters. So this capacitor filters are the very essential electronic components, and hence they have some very good performance. So based on which parameters their performance is analyzed, like cutoff frequency, impedance, capacitance value. So the first key parameter for these essential electronic components for capacitor filter is cutoff frequency. Frequency at which the filter starts attenuating signals. So we if we done any experiment about these capacitor filter, then we get some graph, and that graph or any other value at which the frequency or the filter starts attenuating signals, means it gets the signals, that frequency, that value, and that specific region is cutoff frequency. So depending upon these cutoff frequency parameter, it performs very effectively, very efficiently. And next, impedance, opposition to the flow of alternating current. Here, opposition to the flow of alternating current means we have learned the basic principle that allows the alternating current and block the direct current, like this impedance, which increases with the increase of frequency and decreases with the decrease of frequency. Next, again, the third parameter is capacitance value, measure of capacitor's ability to store the energy or signals. We know that generally capacitor is means storing some energy or some type of frequency, etc., etc. So depending upon this capacitance value, also the capacitor filters works or performance. So the cutoff frequency, impedance, capacitance value are the key three parameters behind the performance of capacitor filter. So we have, cutoff frequency is frequency at which the filter starts attenuating signals, means at which point, at which region, specific region, this frequency starts or filter starts attenuating signals. So next, common capacitor filter applications. At starting slide, we have studied or noted that we will learn about the performances and basic principles, and lastly applications of these common capacitor filters. So the first application is power supply regulation, audio signal processing, signal conditioning in sensors, EMI separation. We know that the general or main performance of the capacitor filter is to attain signals or to pass the signals. So power supply regulations, we have learned also the use of common capacitor filter are to pass the power supply regulation, and it also passes the audio signals, and it passes the signals in sensors also. And for EMI separation also we use capacitor filters. So these capacitor filter nowadays are used in many sectors. In every sector, audios, sensors, EMI, power supplies, in various sectors. So these are the major applications of common capacitor filter. So material and construction variations. So the materials by which these capacitors are generally made are ceramic capacitors, electrolytic capacitors, film capacitors. The ceramic capacitors are of low cost and very small size and high stability. So this is the advantage of using ceramic capacitors for the capacitor filter. And electrolytic capacitors, and these have high capacitance and they are polarized also. So high capacitance is the major point here to use these electrolytic capacitors, because it is the main key parameter, capacitance value, in the performance of these capacitor filter. And next, film capacitors. These are also having good stability and low losses. If we have low losses, then we get more profit. So this is also very main advantage of material and construction variations in these capacitor filters. Essential design and considerations: impedance matching, frequency response, environmental factor. These are the essential design considerations in capacitor filters. So future trends in technology: mini, advanced, and smart. These are the future modern trends in this capacitor filter technologies, like miniaturizations, advanced materials, smart integrations. So this is about capacitor filters. Thank you, ma'am, for giving this golden opportunity for me.